The next task in our class is to work on something called functions. Functions are these really handy structures in any programming language, really, that can be used to do a bunch of things that clean up your code, organize your code, and make it so that you're not always reinventing code that solves a problem. Once you have it working, you know it's going to work in another place. So let's take a look at how we can use functions to clean up code that we already have. I am using my list of robots that I have in my previous video. You can see the list. And this first robot, the Robonator 5000, is what I am using to demonstrate some things here. So I am taking the Robonator 5000 here. This is my test robot, and you can see I have an if-then statement saying if testrobot.robotType is flying, print the robot can fly, otherwise this robot can't fly. And because the Robonator 5000 is a flying robot, this prints out that this robot can fly. Now, there are a few things that we can do to make this more useful. If I want to, for example, try the same code again, but on a different robot, what I could do is I could set test robot to be the next robot in the list. This next robot in the list, you can see, is Big Dog. And let me change this to var so that I can change its value. So test robot is equal to test data 1, and now I know that this is the second entry in my list. So now if I run the code, we can see I have this code running from start to finish. And this time, because I'm setting test robot to now be the second robot in my list, now, because Big Dog is a walking robot, the second statement is instead printing, so this robot cannot fly. But this is kind of annoying because you'll notice this is really the same structure of code. We get a value, we get a robot, we check that robot using an if-then statement to see which print statement I'm going to use. It's the same thing for our second robot. Anytime you find that you are repeating the same structure in code, this is a great candidate for writing a function. So let's write a function that takes care of this for us. So the idea behind this is, let's say that we want to write a function that takes, for a given robot, so we're going to give the function a robot, print a statement that says whether or not the robot. So this is the notation for doing this. I've defined a function called print flying statement. This function takes a robot as the input. So this means whatever robot I use as an input to this function, my code is going to use this to print out an appropriate statement. So I'm going to copy my if-then statement and paste it inside my function. But this time, instead of test robot, I'm going to make this robot. Because this robot is whatever robot I take in to my statement. And so it's the robot that I take into my function. And so now, what I can do is I can run print flying statement, and I can pass a robot into this function. I'm going to make this test data 0. So I'd like to get the same behavior as what I got in the code above. Now, one thing you'll notice is that nothing is really happening. This is because when you print a statement inside of a function, because it's happening inside the function, we have to look carefully to see what it's actually putting out. So we can see up here, this robot can fly is what was printed out, and that is because we passed it the first robot. If I now want to do the same thing with the Big Dog robot up here, or the one that I was using before, I just have to write this statement one more time. But instead of using test data 0, which is Robonator, I change this to test data 1. Now you can see that now we have this printing out, this robot can fly for the first one, and this robot cannot fly for the second one. Sometimes just using print as the output of a function can be not that useful because we don't exactly know what this function is giving for each individual piece. So what we can do instead is we can make it so that the function actually returns a statement that can then be printed out. Let's see what that looks like. So there's a lot going on here, so let's take a look. This function generates a flying statement about whether the robot flies or not. This says that I'm taking in as an input a robot. This additional notation out here says with the arrow that this function is going to give out or output a string at the end of it. So what I'm doing here is I'm creating a string, and I could give it the type of string here, and I'm going to set this flying statement to be this robot can fly if the robot that I've input, if its type is flying. And if the otherwise, I'm going to set flying statement to be this robot cannot fly. And at the end of the function, I'm going to return flying statement. So whatever version this flying statement variable has been set to, this function is going to give back that string, which again is what this means up here. So let's try using our result up here. But instead of print flying statement, I'm going to use my generate flying statement. And I'm going to set a variable. I'm going to say let first robot statement equal this, and I'm going to do the same thing for the second one. So let second robot statement be this one. As you can see, this is a statement, and I'm going to set it equal to whatever this function gives out. Whatever it returns is the word that we typically use. So if I run my code, I can see that if I click on first robot statement, it says this robot can fly, which is the same as what happened above. The second one, which I'm calling on Big Dog, says this robot cannot fly. And so now I can see that I am doing the same thing over and over again with the different robots in my list. Now that I have written this code, I can use what I know about loops to actually use this function for every single robot that's in my list. So this is using a for loop. For every robot in my test data, I'm going to define a new variable that is robot statement. That's going to come from generate flying statement, and it's going to, the input for generate flying statement is going to be the current robot. So I could even make this a little more clear by calling this current robot, and then using that variable name inside my generate flying statement. And so for each robot in my list, that's this list right here, it's going to create a robot statement based on the flying value of the current robot, and then it's going to print that robot. If I run my code and I go to the print statement, you can see that this just says this robot can fly, but let's actually turn this into a list so that we can see all the values that come out. And so this is alternately going through the list and printing out a statement one way or the other as to whether the robot can fly. Now, I could make this even a little more clear by actually saying the name of the robot in each statement. So let's use some string interpolation to do this. So what I've done is I've added in some text here, and I'm using current robot.name as the name of the robot. And then I'm just putting in the value of robot statement. And so what Swift is going to do for each robot is create a variable that represents this flying statement, and then it's going to put it in to this location in the string using this function. And notice this has all stayed exactly the same. I haven't changed this function at all because I know it does what I want it to do. So let's run the code. So if I now go to the print statement and I add the viewer, I can see that it's actually giving me some information about each robot in the list. Let's see if I can make that a little bigger. There we go. And so now you can see that it is printing out a statement, although it's a little bit hard to see in some of these. It's printing out a statement for every robot in my list and is stating whether or not the robot can fly. Now to wrap this up, let's change this a little bit so that I can actually see the output of each of these functions. So I'm going to shorten this string up here in my generate flying statement. I'm going to change this to just can fly or cannot fly. And I'm going to shorten this string as well. So the robot named. And so now this is just going to have within it a complete sentence that corresponds to each robot in my list. Let's run it to see what comes up. And so you can see in my list now, this has all of my robots. And you can see that it is alternately creating a sentence that it can fly or it cannot fly. Let's see if we can even simplify our code a little bit more. Let's create a new function. So what I've done is I've taken this iteration over a list of robots and I've actually put it into another function that I'm calling goThroughRobots. And I am including as an input called robot list an array of robots, which is basically my test data. And so the rest of this code is exactly the same. I'm basically using my generate flying statement code. All I need to do now at the bottom of this is to actually call my list. So I can make this test data. And when I run this code, this is, again, printing out statements for each item in the list. And so I've taken all of this code of iterating through a list, and I've turned this into a single clear function that just says, goThroughRobots. And there are a lot of ways that this can actually organize your code. In the next video, I'm going to show you how we can actually take a whole bunch of code that's already doing something and organize it into smaller functions that each perform a specific role. And so that's going to show you how we can use functions to organize our code a little bit more than we might otherwise. See you there.